Okay, let's continue on with lesson 2.5. We talked about inequalities. Now let's kind of look at all three of them together and then how that gets put together when we solve equations or inequalities. So comparing again, take a look at this table, kind of explain some information as we go from these symbols to what does it mean, and then some comments to further explain. Your x is just a variable. It just represents some number. X equals 8 is an equation here that says the number we're thinking about is equal to 8, whatever that is. It's an equation. This is an inequality here. The number I'm thinking about has to be all the numbers smaller than or less than 8. X, the number that we're thinking about, can be any number less than 8. And then you get into an expression here. The number I'm thinking about, add 5 to it, right? The number that we're looking for, add 5 to it. Whatever the number is, right? It's an expression. This is an equation. You would then solve it. X is some number. When I add 5 to it, I get 8. What's that number? That's an equation. You're looking for the value that makes both sides true. Here again, what number plus 5 is less than 8? There's a whole range of values, a whole set of those values. And so that's why the solution looks different, because there's more than one answer to make this true. And so looking at that again, how that turns out, here are two examples here. X plus 5 equals 8. X plus 5 is smaller than 8. And then you can see what's happening. And I like to see where they're showing the check. In this case, we've been not showing that above, but you can always check your answer. So you would look at that to see if it's true. Notice the interval notation is another option, right? Remember, you want to know the interval notation. All the numbers from negative infinity to positive 3, always from small to big. That's what that notation, or all the numbers smaller than 3. And then we're looking at here, again, I solved these already. This is an inequality. This is an equation. Notice, again, the representation's a little sloppy, I apologize, but all the numbers bigger than 3. Here, this is an equation, so it's just one answer, x equals 1.5. And as we go through that, again, here's another example. This one is x is less than 1.5, so you can see, again, that notation. I probably should add, as I'm looking at it, let's quickly add the interval notations for these. So the interval notation for this is all the numbers from 3 to positive infinity. I like to show it here from 3 to infinity. Here, this would be the numbers from negative infinity all the way back to 1.5 in a bracket in this case, because it's a less than or equal to, it's a closed circle there. Now we go into some of the more complex situation when we multiply an inequality. Solving inequalities, right? It's a little different than equation, especially when we have these, where we're multiplying or dividing by a negative value. And so we have this situation where these two inequalities are true. Multiply both sides by 3. Take a look at what happens. These statements are still true. So when I multiplied by a positive 3, it did not change the outcome of those statements. They're both true. However, when we multiply by a negative 3, what happens is these statements are not true any further. And so what has to happen is we need to change the symbol to make one of them true, in terms of we have to change the symbols, reverse them to make them true. Negative 3 is not smaller than negative 6. 3 is not smaller than negative 6. So the symbols would have to be changed in order to make those true. And so that becomes the technique we use. We flip the signs, or flip the signs when we multiply or divide by a negative number. That's what's going to happen here. Or let's multiply. Then we do a division 1. If you see kind of that same situation happens when we're dividing by a negative number, you end up with statements that are not true. Negative 2 is not less than negative 4. If you think about it, right, negative 4 is further to the left. So it's not true. So the only way to fix that is to flip the signs. And so that's what happens on this problem here, not with an you can't flip a sign on an equation. I guess if you flip the sign on an equation, it stays the same. But here, in order to solve it, we needed to, right there, we needed to flip the signs right there. After we divided both sides by -2, you have to flip the signs, and that's your solution there. So again, you'll get to practice it on your homework or your prep work.